We're still IT are moving, but they are moving unfortunately a bit slowly with making sure we've got everyone's BCU email addresses. We want to make sure everyone was sorted rather than half of you sorted and half not, ideally. So we will still be uploading recordings to the YouTube channel, and then after a while I'll move them from there just onto the Microsoft Stream so that you can view them inside. Although for some of them it might be worth keeping them on YouTube so that when you're finished your time at BCU, if you need to ever go back to stuff, you can still go, it'll still be there. I don't see YouTube going anywhere anytime soon. So okay. So today we're going to be talking about security, privacy, compliance, and trust with Microsoft Azure. Feel free to, I'll try and keep an eye on the chat, but if I don't see a message, just unmute yourself and jump straight in with a question. Okay. Great. So as ever, start off with the learning objectives. So being able to describe secure network connectivity in Azure, core Azure identity services, so identifying the identity of a user, security tools and features, governance methodologies, reporting, and privacy, compliance, and data protection standards. We're starting to touch more of the cyber aspects here that would typically be for a physical compute system, that even if you're a cloud or a server engineer, you wouldn't be responsible necessarily for all the server and compliance and security aspects there. So we are slightly outside of what the job might be with some of these things, but you do need to know them, because if you're working in a small organization, you will need to be able to do some of them naturally. But also, if you're a larger organization, you may interface with some of those departments. So it's quite important that you know the terminology and the features, and can at least find out what a problem might be if one's occurring. So securing network connectivity. So defense can be thought of as this hierarchical system generally in terms of computing. So you've got a layered approach to securing computer systems. So we want to have multiple levels of protection wherever possible. And we need to be able to isolate attacks against one layer from subsequent layers. So if we start at the top with the physical security, door locks and things, identity and access, so making sure that someone can't get in unless they meet the specified requirements. Perimeter access, so it's making sure that someone can't access the physical or the online area from up to a certain perimeter. Obviously, there'll be some interaction with cloud systems, but you want to give them access to certain parts and no access to the secure parts. Okay. Then you've got the network, so you need to make sure that if they are onto the network, that they only access the certain parts of the network that they're allowed to access or have permissions, and not trying to access things that they shouldn't be. Just because someone's met the identity requirements doesn't mean that they're always going to access the parts of the network that they should be. So you can have people mimicking identity access, or just people maliciously using their credentials to try and access other parts of a network that they shouldn't be. Then we've got the physical compute and practical side. So if there's malicious code or applications going on in there and doing things nefariously that they shouldn't be. So ideally, you need to have everything verified before installing or setting up on the cloud. Fortunately, we're going to be sticking with just mostly Azure specific services that then have been verified by Microsoft as being secure and safe to run. And then you've got the data at the bottom end. And this often is where your value, your privacy, your security, your business reputation sits. So it's really important to make sure that the data at the bottom end is as secured and well defended as possible. So in a shared security system, there's sort of this migration from a customer controlled to cloud-based data centers, and that shifts the responsibility of security. So if you've got on-premises, so a server farm that you maintain, you're going to be running that here, and that's all down to you in terms of the customer or the user being responsible for all of these different things. But as you move up through the stratified levels of cloud provision to infrastructure as a service, you've got Microsoft being responsible for certain parts of security, and this weird sharing of concerns of security measures between Microsoft and the customer of Azure, for instance. When you go to platform as a service, you've got Microsoft and the customer being responsible for certain parts, but Microsoft being responsible for the operating system in particular as platform as a service. And then when you move to software as a service, Microsoft takes on more of that responsibility. But there is still this customer element in terms of account management, client endpoints, data governance, and the identity and directory infrastructure. So even if Microsoft is hosting your software, you still need to make sure that you're securing the identity and the directory structure of the users that are going to be actually interacting with that software. So Azure Firewall is a stateful managed firewall as a service, which they use the acronym FAAS, and this grants or denies server access based on the originating IP address. So the address that's linked to your computer, specifically that machine, and this is to protect network resources. This applies inbound and outbound traffic light filtering rules. So it comes here and it either hits the green, amber, or red traffic light, amber being under investigation, red being banned. Okay. So it's built in high availability, unrestricted cloud scalability, which is really, really valuable here, especially if you're getting attacked by a denial of service attack. And then it uses Azure monitor logging. Now, despite being a massively Windows-oriented organization, Microsoft Azure is apparently protected by a wall of Linux computers, which was always the standard and often looked down on way of doing computing by Microsoft, but it's the only thing that reliably works 100% of the time. You've also got this Azure Application Gateway, which provides a firewall, which is a web application firewall, or WAF. So WAF provides centralized inbound protection for your web applications. And if you're interested, you can find out more information about the Azure Firewall here. So, has anyone heard of denial of service attacks or DOS attacks?
No.
No, great.
Oh,
Sorry. What is it?
Okay, so you've got a website with a secure login area, right? Which, like pretty much all of them have now, a area that you log into to get your account or your access or whatever. So what happens if you type in your password wrong?
You get denied access.
Get denied access. What happens if you did it 10 times, 100 times? That you're getting denied access 10 times or 100 times, yeah? And each time the server, every time you go and try and log in, the server takes the input to the email address or login box, and the password box goes to its database. Security goes, is this the right email and password? Oh no, it's not. Okay, never mind. You can't log in. So it's doing an SQL or a server database check on you each time, which takes an amount of compute power. It takes a small amount of compute power to check for one person and to let them log in. The thing is, if you do that 1,000,000 times, that starts to take longer and longer, and to back up the amount of requests that the server is doing. So the way that a denial of service attack works, and this was historic that it would work this way, but a denial of service is where someone's written a computer program so that, say, my laptop is going to try and log into my Amazon account with the wrong password, and it's just going to keep doing it and doing it and doing it and doing it, and it's going to do it 1,000,000 times, or a trillion times. And even if it only takes 0.1 of a second for each of those attempts, all of a sudden it's backing up that server, and that's having to focus on my computer, telling it, no, you're not logging in, no, you're not logging in, no, you're not logging in, no, you're not logging in. Okay, so it's doing this over and over and denying my laptop service. The thing is, I've designed that program to make my laptop get denied, back up that server, and cripple the way that server can then deal with everyone else who's trying to log in, everyone else who's trying to shop. So that server is then very busy trying to deal with me, can't host the website, can't do a database check for anyone else, and therefore that's a problem, and it falls over. Eventually it says, it's just trying to do, too many database checks and in a short time, and it crashes. So that's a denial of service attack. And 30 years ago, that denial of service was in and of itself a bad thing. It folded over credit card companies sometimes, rarely, but there were a couple of times that there were big denial of service attacks where criminal gangs or hackers had generally got a powerful enough computer and a stable enough internet connection to get a computer or a supercomputer to constantly request access. The thing is that it's quite easy with the cloud system to avoid. So you just have two computers that are hosting the website at the same time and are doing the database checks, so that even if one's getting bogged down with loads of service or denial of service requests, the other one's doing fine at hosting the website still. So you compartmentalize. So the way that they got around that as a criminal gang, as a hacker front, was using distributed denial of service attacks. So instead of just getting one computer to constantly request access, you use a cloud of computers or a network of computers, so that 100 or 1,000 or 1,000,000 different computers are constantly asking for access. So instead of it being 1,000,000 requests in a minute, it ends up being 1,000,000,000,000 requests in a minute. So even a very well secured, and powerful cloud website system and a strong database sat in the background that's really fast access, even that will get bogged down with a distributed denial of service attacks. And because it's done from multiple different computers in a distributed way, you can't just say, you're constantly asking for access, I'm going to deny your IP, I'm going to block your IP from coming to my website, I'm going to block yours, because they just keep springing up more and more cloud instances or more computers with different IP addresses. So it's not as simple as just going, I'll just block you from asking for access, I'll just block you. So that's when it becomes difficult. Fortunately, cloud providers have put a lot of work into getting distributed denial of service protection, or DDoS protection. Does that make sense? What DOS and DDoS is then?
Yes, so maybe a question, if that's okay. So I guess with cloud, you have the scalability. So if you have a DDoS attack on your system, you can scale up your computing power to process that, right? But also with that scalability, I assume will come increasing costs to the organization. So even if there's no security breach, is there still a negative impact on that company if they're under attack due to the increased cost?
Yeah. So there is, the theory is that the increased cost of scaling up your compute power on the cloud to deal with the DOS attack or DDoS attack is less than the cost of your website going down for 6 hours.
Okay, so there'll be a balance point where it's more viable to go under than to sustain the defense.
Yeah, take Facebook. It's down for a few hours, lost 6 billion value off Mark Zuckerberg's shares, let alone everyone else's, and the advertising revenue and things. So you're talking hundreds of billions of dollars that were lost in that outage that happened the day before yesterday. So that we're in that high octane fueled. Everything needs to be available all the time, 100% working for me to make me as much money and not lose out.
Yeah. Okay. Cool.
Okay. So what the DDoS protection does, and the way they've worked it, there's no perfect way of preventing this. There's always going to be a way that hackers and criminal gangs find ways into systems or can do nefarious activity, as we call it. But so the DDoS attacks that overwhelm and exhaust network resources. The protection sanitizes unwanted network traffic before it impacts service availability. So you've got basic service tier is automatically enabled in Azure, and then you've got a standard service tier that adds mitigation capabilities to protect Azure virtual network resources. Now, outside of cloud providers, you get there are some very advanced security and cybersecurity companies, and one of the cool tools that they often tout, and it seems to work very well if you're careful, is called a honeypot. So the idea of a honeypot is that you have a separate system that's outside of the cloud or outside the main website and database for that company that looks like that company, but they call it a honeypot because it's very attractive to bees. take that analogy over, if you think of the bees as the DDoS attack, so a swarm of bees is coming in to try and attack the website, and you take the honeypot that looks like the website, that acts like the website at first, but actually every bee is drawn to that honeypot, it keeps the actual website working, and all the bees have gone that way and are attacking the honeypot and busy trying to make that fall over. And the idea is that whilst the bees are attacking the honeypot, the cybersecurity company can see where all the bees are coming from and then hack them back and then crash them rather than the other way around. So you end up with this almost cyber warfare situation going on with that, or they have other measures that they can put in place with the honeypot, but it just is an added layer of protection. So Microsoft will have other cybersecurity companies or cybersecurity divisions of the company on standby, ready to do things like that if Azure is under big attack. So we've got network security groups as well. So these are filters, systems that filter network traffic to and from Azure resources on Azure virtual networks. Okay, you can do whole degrees and masters and additional, beyond qualifications in network security and things. So we're not going to go into much detail there, mostly because it's well outside of my own computational expertise. So I don't want to give any false information or things about that. But you can set inbound and outbound rules to filter by source and by destination IP address, so robot IP being the address or the name of that computer in essence. You can add multiple rules as needed within your subscription limits. And then you can apply default baseline security rules and override these default rules with high priority rules as well. So if you need to make sure that certain people have a higher priority access to your system than others, then you can do that. Then there are security gateway groups too. So individual groups of servers or port filtering requirements or servers with similar functions like web servers, and you can have the same security rules and things operating for those, just to make management so much easier. You don't want to have to come up with 1,000 different network and cybersecurity rules for each server that's running when you've got 100 servers running the same system in parallel. So this allows you to reuse your security policy, and it handles the complexity of explicit IP addresses and multiple rule sets, allowing you to focus on your business logic. So Azure supports combined network security solutions. So you can look at the network security groups with Azure Firewall, or WAF, and the Web Application Firewall without Azure Firewall. There's some a walkthrough example that you'll go through the Microsoft Learn portal that will talk to you about securing network traffic and how to set up some of these rules. But that's done as a set instruction thing from them. So I'll leave that to the Microsoft Learn platform for you to go through in your own time. So we're going to talk about some of the core identity services as well. There's going to be some stuff in there that you're going to go, I don't have a clue what that word means or that thing means, or if you're still not sure about what IP address means, stop me now or as I get to that point, and I'll try and add some more detail to those things. So there are two concepts fundamental to understanding identity and access. So we've got authentication on the left. So this would be identifying the person or source or service, seeking access to a resource. It requires legitimate access credentials, and there's a basis for creating secure identity and access control pipelines. So for BCU now, for authentication, we have what we call multi-factor authentication. So every time I want to log in to my computer, I can open it, fine. If I want to log into my emails or to Teams, I need to use what we call multi-factor authentication, where it texts my phone or calls my phone and gives me a 6-digit code every time I want to log in afresh, or if it's timed out the login, which is good for a security point of view, but if you're somewhere where you've got Wi-Fi but no phone network, you're stuck out. So it can be restrictive. Then you've got authorization. So this determines an authenticated person's or service's level of access. Where are you going to let them get to? Do they have access to this bit of information, to that part of the database, to do these queries? Are they restricted from doing X, Y, and Z? So this defines which data you can access and what you can do with it. Microsoft Azure's cloud-based identity and access management service is called the Active Directory, or AD. So you've got authentication, where employees sign in to access resources, single sign-on, where you just sign in once and then you've got access to that forever. You can manage that in terms of the application management, give access for a certain period to do certain things and then remove them. Business to business, or B2B, you may have heard the acronym, where if you're a business giving an entire other organization access to certain privileges and things, or you've got B2C, so business to customer, where you're giving it to specific email addresses or users. And then you've got individual device management too. So as I was just saying about the Azure multi-factor authentication, so this provides additional security for your identities by requiring 2 or more elements for full authentication. So you need to give, as well as your username and password, something you know, possess, or something you are as well, just that additional level of proof. Some systems are requiring face identification or fingerprint recognition systems as well at the moment. So, security tools and features is the next section. So you've got this whole Azure Security Center to look at, and this is the monitoring service that gives you threat protection across all of Azure and on-premises services. So you've got your security recommendations based on your configurations, your resource, and your networks. And this is actually, 10, 15 years ago, you might not have thought this as so important to be able to monitor threats and the services. Either you're going to get hacked or you're not, as a small and medium enterprise. But now it's really important based upon data protection, GDPR, and the reputational impact of having to go out to say to all your customers, sorry, we've been hacked. And it can happen on a large scale or even a smaller scale. But a couple of years ago, I had some work done at my house, right? So we got a building company in to do the job, and they sent an invoice. And then a couple of minutes late, so they emailed through the invoice and asked me to pay. And a couple of minutes later, they sent through another invoice that had slightly different bank details on. And they said, sorry, we've updated our bank details. Here you go, which was really odd. So me knowing a thing or two about computers, I thought, well, that's weird. So I called them up, thinking, which is it? Have I got the right bank details? And they had no idea that someone had hacked into their email address. And if it weren't for me telling them, they'd have lost out on thousands and thousands of pounds from all the different customers that had been emailed that day to say, you've given us two invoices, or we've paid you already, or why are you asking us for that? And so they just had no idea about on-premises security. And it turns out their own computer system that they were using, through Gmail and all that stuff, just wasn't secure enough for them. So they've been hacked once before and weren't aware of how to protect themselves. So I think they needed a cloud-based system where they could look at threats and be serious about their cybersecurity. Even on that, just a few builders and someone working in the admin office. So the cloud can be a much safer way of working. So this automatically applies security policies to any new services in your provision as well, so it templates them for you. So there are multiple different scenarios that you might be working in here with the security center, where you can detect, assess, diagnose, stabilize, and close. And in general, if you've got an online system that's got secure information on that someone is attacking, you need to close that down quickly and then see what could be salvaged. If you've got a ransomware attack happening, which is happening more and more internationally, has anyone heard of ransomware attacks?
No.
No? Okay. So this is something it's hitting the news here and there, but not as big as it should be. They are a massive issue at the moment. So you get if someone has hacked into your computer, say, or your systems or your servers or your online platform, and then changes all the passwords. If it's done to your computer, they typically lock your computer and have a screen up on there. So it just shows a screen, almost like a PowerPoint slide, that says your documents have been locked. We've got access to all your photos, your information, your password, your emails, all your stuff. we own your computer now. If you want your stuff back, you need to pay us £5,000, £10,000, or even worse, you need to pay us 200 Bitcoin. And this happens to people, small businesses. It even happened to the NHS a couple of years ago. So there are entire NHS trusts that got hit with ransomware attacks, where a criminal gangs had grabbed hold of the NHS systems, shut down entire networks and small areas of the computing teams at certain hospital trusts, and this was starting to spread. So they had to close it down, shut down those network and firewall those systems to make sure the hackers couldn't get access to other bits of the network and the other data that was patient secure and specific. But there was a very real question then, do we pay the ransom? And it's strongly recommended that you don't pay the ransom, because that's fueling them, and you had no guarantee of getting your information, your data, your security back. No guarantee that they haven't copied it off and are doing something else with it. So what do you do then? How have you lost your data? Well, if you've backed it up, no, you're safe. But more than just going, okay, well, we'll just reformat our machines and then put the data back on, you need to work out how they got access, because there's nothing to stop them doing it again and again and again. It's probably worth having a quick Google after I finish talking about this, about ransomware attacks and what you can do to protect yourself from a ransomware attack, and what you should do if you are subject to a ransomware attack. Okay. Does that make sense?
Yes.
Yeah, so if I so we've got, there's right now, yeah, so Washington Adventist University in the US is currently undergoing a ransomware attack. I was just trying to get the picture up of what is showing on the computer. It's not showing. This was the one from the NHS, I think. So yeah, we've got it here. But it's also one that goes into a lot of individuals were caught by this too. This was back from 2017, so it was the big NHS one. But so yeah, your computer's locked. You try and hit X, but it just reopens, and you had to pay either through Bitcoin or another way. But you had to go to that address and pay Bitcoin. Now back in 2017, that 300 Bitcoin was probably worth about 5K. It's 300 Bitcoin now, 300 Bitcoin now. Oh, sorry, that was $300 worth of Bitcoin. So yeah, it's a much smaller amount, $300 to get your files back, which may seem not that bad, but you pay them and then, you know, you're going to get hacked again, no doubt, very soon afterwards. So we've got the Azure Key Vault here. So this stores application secrets in a centralized cloud location to securely control access permissions and access logging. So it's very good if you've got very secretive information that you need to keep the security and the provenance of for your customers. So you've got key management, certificate management, and you can store the secrets backed by hardware security modules. There's a walkthrough to go through in terms of the Key Vault on the Microsoft Learn platform as well. Then we've got Azure Information Protection, and I think you're hopefully starting to get an idea that there are just tons of different Azure services and solutions and systems in there, and it's very easy for us to go, you can use this for this or this for this, and that's kind of what this whistle-stop tour is doing. But the fact that you get to go a bit of a hands-on example through the Microsoft Learn platform is good, and then ultimately it's going to be whatever your organization that you work in is using that you need to be familiar with. But you can upskill quite quickly when you know what they are and what they do. So Azure Information Protection, or AIP, this classifies and protects documents, emails by applying labels to them. So automatically uses rules and conditions defined by your administrators. You can either manually define them or by combining automatic and manual methods guided by recommendations. So any documents that have certain bits of information need to be treated with this way. Emails that look like this should be treated like this. Another common area of cybersecurity that's a big issue at the moment is called spear phishing or phishing. So that's PHISHING. So phishing attacks are generally you get an email that's sent out to loads and loads of people to say, your details have been compromised. Please click here to update your password. So type your username, your old password, and your new password in. It doesn't actually change your password. It just takes your old password, and then the hackers have got your username and your old password, so they can go and log in and get all your details, or get access to your bank details, or your credit cards and all your stuff, your Amazon account that's linked to your card. So phishing attacks are quite widespread. Then you've got the more advanced ones that are called spear phishing attacks, where rather than just sending an email out to 1 million people and seeing who responds, spear phishing attacks are more targeted, like when you're doing spear fishing in the sea to catch fish, right? So spear phishing attacks are targeted to a certain set of individuals to try and get specific things and specific access. So you might target students at BCU to try and get access to BCU's student mainframe. Okay. Ideally, you've got automatic and manual rules for emails and for access requests and things and communications and documents going through the servers that prevent spear phishing or phishing emails. We actually did a test at my old organization, and it was incredible. The IT team tested the staff and the students to see who would fall for a phishing attack, and it was incredible. It was at least 60% of people, I think, clicked on the links and fell for it, and the 30% of those that didn't just hadn't opened the email anyway. So it really didn't look. There was some IT education to do after that point, should we say? So last one I'm going to talk about is in terms of a service. We've got Azure Threat Protection. So this is a cloud-based security solution for identifying, detecting, and investigating advanced threats. So things like compromised identities and malicious insider actions. Now, compromised identities aren't the easiest things to detect, but there is an active area of research going on here. In particular, we try and identify what's normal behavior for an identity or for a particular user, and what's then abnormal for them, sets off alarms or alerts, and then that identifies it, notifies the threat protection systems in cloud-based services. They're still quite new. They're not brilliant, but I don't know if anyone has ever had a bank card or a transaction cancelled, or there's the verified by Visa system that you may have done with online shopping, where you needed to type in your additional password or information for a few purchases, and then over time it's gotten more used to who you are and asking less and less for you to confirm your identity or for you to type in your verified by Visa password. Has anyone found that online?
No.
No, maybe just me. It might be that I buy a weird eclectic mix of stuff. So that was one of the systems that was put in place by banks to try and say, instead of fraudulent transaction of them just cancelling cards or locking down accounts, they would ask you to type in an extra password, the verified by Visa password for that. And over time, it would get to know who you are, what kind of things you bought, and it would ask you for the password less and less. So what about governance? So Azure policy is there to help you stay compliant with your corporate standards and service level agreements. And this is where we get into the large organization scale, where you've got things like service level agreements set up, or policies set up, and governance structures. You're not going to be doing these things on your own for a while if you're in the cloud environment, and you'll be more advanced in terms of your cloud credentials and your cloud expertise by that point. So you'll have policy definitions to enforce rules and effects for your Azure resources. So you'll evaluate and identify resources that don't comply with your policies, where access is open to certain bits of information that shouldn't be, or where people aren't being treated, or their data isn't anonymized when it should be. So you've got built-in policy and initiative definitions under categories like storage, networking, compute, security center, and monitoring. In terms of IT, in the nicest possible way, people who are in charge of IT policy tend to be the more boring and legalistic IT professionals, but they have an awful lot of power in organizations, because if you're not compliant, then that's a big issue for you. So in order to implement Azure policy, you'd create a policy definition, say customers should be able to access their own information, but should not be able to access anyone else's information. So you assign that definition, and then you review the evaluation results. So is that the case, or are customers able to get other customers' information? So policy definition expresses what you want to evaluate. You can implement the policy definition by assigning it to a group of resources, and then you can review the results. So it's almost like a self-check on the cloud system. So you can have your initiative definitions and then assign them to a load of virtual machines, storage, and databases, for instance. So the policy initiatives work with Azure policies. So you've got initiative definitions, which group multiple policy definitions into a single unit to track compliance on a higher level scope. And then initiative assignments are assigned to specific scope to reduce the need to make an initiative definition for each scope. And there's a walkthrough to look at creating an Azure policy online. So, and we've got role-based access control, which was more of the traditional way of working rather than an individual thing. When you got to a large organization, you'd create groups or roles. So this is fine-grained access management. You'd segregate duties within your team and grant only the amount of access to users they need to do and perform their job. So this enables allowing or disallowing access to the Azure portal and controlling access to resources. So you've got the users, you've got the apps and the user groups, and then you'd specify those through the Azure Active Directory and give them access to certain things in resource groups. A bit like how you previously on a computer may have had administrators, managers, users, etc. And there's a walkthrough online for that. There's also a walkthrough for a lot of the things that I introduced in the second video that you watched on Monday, to things like the SQL database, where you create one of those online. You can lock certain resources, whether they should be read, update, or delete, and whether they can be read-only. Ideally, you want to make sure that if someone needs access to something, they can read or update it, but they shouldn't be able to delete. Only people with sufficient or significant access should be able to delete data and information, given how cheap the storage is. Okay. We've got Azure Blueprints. So this creates a reusable environment definitions that can recreate the Azure resources and apply your policies instantly. So if you need to go through an IT security audit, or if you're needing to recreate or multiply scale up your cloud systems, you want to create the blueprints first, and then you can template everything much easier. So you associate blueprints with specific Azure DevOps build artifacts and release pipelines for rigorous tracking. Okay, that's when you get into the sharp end of the stick of the IT and cloud system templating creation and security operations. Then there are three main aspects to consider in the relation of creating and managing subscriptions. So you've got billing. So this is the reports and chargeback that can be generated per subscriptions. Access control. So subscription is a deployment boundary for Azure resources and can set role-based access control. And then there are limits to your subscriptions. So they're also bound to some hard limitations. If there's a need to go over those limits, then additional subscriptions can be needed. If you hit a hard limit, there's no flexibility. So this is making sure that you don't spend money or do things that are outside the remit for your organization. Okay. I had a message from someone on the bootcamp. This just reminded me with the Azure. So I'd said about making sure you're set up on Azure. I probably didn't mention this clearly enough, to make sure that you're set up as a student, just with your email address. The reason is you get some free credits, free units. You don't get charged for stuff early on as a student with Azure, and you can try stuff out like through the Microsoft Learn platform. If you get yourself set up properly, then there's the chance that, especially if they've got your card details, if that's part of the setup procedure, and I can't, it's been a while since I've done it, so I can't remember, but that if you use resources that you may have to pay for them, or it may use up some of your credits and things. So just be mindful of that. And if you need to create a new email address, just a new Gmail or whatever email address, Hotmail one, whatever, to then sign up to Microsoft again to do some of the sandbox activities and the activities through Microsoft Learn, then go ahead and do that. As long as for the actual exam we use your an email address that then you can get the digital badge paired with your LinkedIn profile, that's fine. Oh, I'm sorry. So the next thing I'm going to talk about is monitoring and reporting in Azure. So this is something that's actually quite hard when you've got a decent meaty-sized cloud system set up for your organization. Understanding what's actually going on at each point is really quite hard. So they've created a few different ways of doing this. So in particular, you've got tags. So this gives you what we call metadata for your Azure resources. So your metadata might be, who the owner is, what the department is, what the environment is that's done something or created some data or saved some information there. So this allows you to logically organize resources into a taxonomy. So you can then search by owner, by department, by environment, by cost center. And this is a name value pair. So it's very useful for rolling up and billing information. So you can know which departments have spent the most. If you need to tell the marketing department to stop using so much resources online, for instance. You then got Azure Monitor. So this allows you to collect, analyze, and act on telemetry from cloud and on-premises environments to maximize your application's availability and performance. So keeping a really close eye on what's going on. You've got activity logs, metrics, and you can add an Azure Monitor agent to collect operational data for a resource. The thing is you get really fine-grained data there, and actually you can get too much data to deal with. So although you've got this tool there, it may be that it's just not worth your time looking into it, and you just need to tell everyone to hold back on spending so much on Azure. Then you've got Azure Service Health. So this is about evaluating the impact of service issues with personalized guidance and support and notifications. So you've got Azure Status, Service Health, and Azure Resource Health. I think it's pretty self-explanatory here in terms of the health checks that it's doing. In terms of the monitoring style, your Azure Monitor will look at things in this way. So you'll analyze, respond, visualize, and then integrate. So in terms of the analysis, you want to look at the containers, virtual machines, and things, and look for the insights. You can then respond proactively to critical conditions identified and look at the monitor metrics. Visualize what's going on and use tables in Power BI, which is the Microsoft dashboard creating system, and then integrate Azure Monitor with other systems to create customized solutions to suit needs. Okay, and the last major topic we've got today is privacy, compliance, and data protection standards. And this is really important to be mindful of. As part of Europe, as part of the structures and the GDPR and compliance things we've got in this country. I know that the future of those things is somewhat unknown, given that we've left the European Union, and it may be that we keep the same data requirements, it may be that we have other ones. If we have other ones, we'll likely need to be compliant still with European guidelines and UK guidelines, and in the future probably US guidelines too. So that will become a bigger aspect, data compliance and system compliance, especially in the cloud. So Microsoft provides the most comprehensive set of compliance offerings of any cloud service provider. Some compliance offerings include CJIS, so Criminal Justice Information Services, HIPAA, the CSA STAR certification, the IEC and ISO 27018, which is a very important international standard there, GDPR, and the National Institute of Standards and Technologies. So Azure is doing that stuff in the background for you anyway. So in terms of the privacy statement, it provides openness and honesty about how Microsoft handles the user data collected from its products and services. So it's really important to, if you're in charge of compliance, keep track of that privacy statement and see any updates in that. So it explains what data Microsoft processes, how it processes it, and what purposes the data is used for. You've got a Microsoft Trust Center where you can learn about security, privacy, compliance, and policies and features. The Trust Center website provides this in-depth expert information, curated list of recommended resources, and role-specific information, so you can search it all through. There's a walkthrough that you can do with the Trust Center on Microsoft Learn platform to go through that. Azure has this slightly different separate branch as well to deal with government services. So this meets security compliance needs of the US federal agencies in America, so states, local governments, and their solution providers. Okay, they have a UK variant, but it's not as big yet. The UK government's still quite slow on centralized or cloud-based services. Every department in the UK government has its own IT setup, and they're generally quite inefficient, although they're looking to step up there. It's worth also mentioning there's a specific China one. So China's first foreign public cloud service provider is the Azure China 21 ViaNet, in compliance with government regulations. So it's got a physically separated instance of Azure Cloud Services, which is located in China. I'm in a position of power here, so I have to be very careful how I give that information and the way that I impart that to you naturally as a being treated as a lecturer here. But it is perpetrated by 21 ViaNet. So read into that what you will. So there were a set of module review questions, but rather than posting those as a form, and given how well everyone had done previously with the module review questions, I haven't posted those, but there is a knowledge check at the end of the Microsoft Learn tutorial. So the next steps for today, I wanted to make sure that we left some time for people to go and keep working on the blogs, because that is going to be a substantial piece of work. If you wanted to, though, there is the next portion of the Microsoft Learn material to go through, which is located here, which I've just pasted in the chat. So it's up to you. I think it's possibly worth building on the blogs better first and keep working on those, because we want to make sure that we've got a nice high quality document there to share, and that's going to be one of our first things that builds onto your profile that potential employers see. So does anyone have any questions about the security, privacy, and compliance information in Azure?
Yeah, I'm lagging behind a little bit, so I have to do still yesterday's class as well. Sorry.
That's fine.
I couldn't finish yesterday, so yeah, it will take some time for me, but I'll catch up during the weekend.
No, that's absolutely fine. So there's time now. I'm finished presenting Ritu now, so there's time for either to keep working on the blog or to go away and to go through this second set of Microsoft Learn material. And then tomorrow's session will be again self-directed, so it'll be building again, still a bit of time to work on the blog, and there'll be the next portion of the Microsoft Learn platform to go through. But I want to make sure everyone's comfortable with all of that, and then next week we'll be talking about what the exam entails and how we prepare for that.
Okay, thank you.
Does anyone else have any questions?
Could you please send a link of SQL, which you were saying that it is a 14-hour course and it gives batches? Could you send a link, please?
Yes. That'll just take me. Sorry, yeah, you just need to give me 1 minute. I'll just find that out. If anyone else has got any questions, feel free to fire away whilst I search that up. Okay, so this is the link to Credly, which is the 14-hour digital certificate in SQL that was recommended by Mark, one of the other people on the boot camp with you all. I don't know if you're able to speak to that, Mark, or if you're in another meeting at the same time. But so it seems to be a nice and approachable course. But I haven't done it myself, so I can't necessarily endorse it. But it's comes recommended.
Okay, thank you.
Ian, could I ask about the blog post? Is it just about the IAS, SAS, and PAS? Is that all we're talking about in this one, or everything?
That's what I was going to get, just focusing
Okay.
on. Blogs work best when they're they don't have to be a fully introduction to everything cloud and stuff, because you end up writing too much and then no detail. Blogs tend to work quite well if they're like just a short, like very deep jump into here's a this concept, some technical information about that, some information on how it relates to Azure. Great. And it's sort of a nice self-contained, succinct but dense piece of material, and that works well as a blog generally online for people seeing your technical proficiency.
Yeah, just because I was going to ask, especially if we're going to post it on LinkedIn, like you don't want to do like a whole page, do you? So is it just like, I don't know, like 250 characters or?
I was going to suggest a longer thing, but not. So with LinkedIn, you've got the opportunity of doing like a LinkedIn post, and then you can write an actual article on LinkedIn, which is what this blog was going to be. So an article with maybe a picture or two in there. So it will be a few hundred words, like maximum one side of A4 kind of thing, just to make sure that you've got enough. What you want to do is make sure you've got enough technical detail in there to make people realize, oh yeah, Georgia, you know your stuff.
Yeah. So like, is it get saved on like, do you know how people save their CV on LinkedIn, and when you go on their profile, it comes up as like a page or something? Is that what this will save as?
So it'll go, if I get mine up. So you've got posts and then you've got articles. So it goes a bit like a post where you can put your headline, you can write all the information, but then it'll go onto your timeline as a new activity that's happened.
Okay.
So it's that's the way it'll work.
Okay, no problem.
Appear on there, you can share it and see it as a piece of information, and then when they go to your profile, they can see that you've shared that stuff and got that that activity has gone on. But it's not just like it's not one of the core bits of information like a CV.
Okay, perfect. Thank you.
Okay, so I'm gonna I think I'll stop sharing my screen. Yeah, so I'm gonna sign off from the video there, given that we're going to move on to work on the blogs. And if you want to take a break from the blog, then go away and do that second set of Microsoft Learn. But that was the activity that I was going to set for tomorrow as well. So if you want to just get on and focus on the blog, great. And when you've got any sort of a draft, don't worry about the quality of it at all. Just ping it over to me or submit it onto the Teams assignment page, and then I'll be able to give you some feedback on that. And we'll make sure that it's written really nicely and represents you really well. And then we'll give it a few, it's going to be something we'll work on all this week, the rest of the week, and maybe a bit into next week. But and then we'll get that shared online. Okay. So I'm going to stop the recording there. Thanks everyone for attending.
Thank you. Ian, would you